So here's how I literally sped up identifying structural characters in a string by 700%. So I was creating a solution for the 1 billion row challenge, and if you're not familiar with the 1 billion row challenge, you basically have a gigantic CSV which contains lines of city names and their corresponding temperatures. And in the end, you have to report the min, mean, and max for each of the cities. Now, inherent to that task is the identification of the separating characters, which are the semicolon for separating cities and temperatures, and the new line to separate lines. Now, in the baseline solution, I was creating two scalar loops which checked byte by byte for the semicolon and the new line. And obviously, this is not the most efficient way of doing it. Now, modern CPUs have wide registers, for example 128 or 256-bit registers, which are 16 or 32 bytes. Now, using this, we can do 32 or 16-byte comparisons at a time. So by using a 32-byte load with a 32-byte comparison against the new line or the semicolon, and by using an instruction called pMoveMask, which turns the 32-byte mask into a 32-bit bit mask, where the 1 corresponds to a match and the 0 to a mismatch, we can use a cool technique that lets us extract the indices out of this bit mask. On x64, we have two instructions that come pretty handy. And these two instructions are tzcount and BLSR. Now, tzcount stands for count trailing zeros. What count trailing zeros does is basically what it says. It will count the bits that are 0 until it hits the first one. So using tzcount, we know where the first match is. Now, there can be several matches in the 32-byte comparison. In fact, it can be 32. Now, by using tzcount together with BLSR, which stands for reset lowest set bit, we can iteratively count the trailing zeros, reset until no bit is set anymore. And this way, we get a list of indices that corresponds to the positions of new lines and semicolons.